Hey, it's Ryan here, and I have a telegraph for you. Ready? Here we go. Huh? Did you get it? Did you get it? That's the only Morse code I know. The word telegraph comes from, of course, Latin two words, tele and graph. Graph meaning to write, and tele is over long distance. Just like a telescope lets you scope things that are far away, a telegraph lets you graph things from a distance, or write things over a distance, send a message over a distance. That is a telegraph. So a couple primitive examples of a telegraph would be smoke signals. You've heard of this, where they take a fire, a big huge fire, or actually probably a smaller fire, but a smoky fire using wet wood, a stream of smoke coming up from this. Then they'd cover over the fire with a blanket, and they'd move the blanket to the side, and a puff of smoke would come out. And then they'd put the blanket, and a puff of smoke would come out again. They'd create these signals that would rise up. Another ancient example is a beacon fire. You might have seen this in the Lord of the Rings movie. Up on top of the mountain, they light a huge bonfire. And that fire can be seen at the next mountaintop. And when they see that fire, they go to the next mountain and they go. And this beacon travels from mountaintop to mountaintop and is able to send a message relatively quickly across a long distance. But chances are when I say telegraph, you think of the guy in the railroad station with the little cap on going beep 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 beep. I have no idea what I'm saying. I hope I didn't say anything bad. Or maybe the telegraph that gets converted into a telegram, which is written out on a card. Harry is back from the war. Stop. Needs money. Stop. Married somebody. Stop. Of course, now this is ancient technology, but it is the foundation of the telecommunication system that we're still using. And I found out in order to understand a little bit of what's going on today, you need to understand what was going on 150 years ago. Before I get too deep into this, I just want to apologize to any engineers in the crowd. I'm not about to let facts get in the way here today. So what I'm about to say is kind of a broad view, and don't take my word on the nitty-gritty, all right? So we're looking back about 150 years to 1850. That's basically when the telegraph system as we know it kind of boomed. The first telegraph machine basically was a simple circuit device, much like what you might have done in elementary school science, where you have a battery and a wire, and this is not a battery and this is not actually a wire, but stay with me here. You take the wire and you put it on the ends of the battery, and there'd be a light in the middle that would light up when you do this. And just by interrupting that wire, the light would be able to go on and off, right? We've all done this. That essentially is enough for a signaling device, because by interrupting and completing that circuit, you were able to send a series of messages. What we now know as Morse code, which was not Morse code at the time, but it was a series of off and ons. But the very first systems did not use a light bulb, because at the time, light bulbs weren't really reliable. But what they could do is make a little bit of electromechanical motion. I'm going to take a little side trip here. If you have a compass, which I don't, but if you pretend this is also a compass, and you have a piece of wire, and you wrap the wire around your compass, if you were to run electricity through this wire, all of a sudden your compass needle is going to go from north and go off to the side, because that circle of wire creates electromagnetic interference, which affects the needle. So using electricity, you can create movement. The first telegraph machine, well, not the first, the second telegraph machine used a little thumper using this electromagnetic action to move something to make a tapping noise. So the tapping would be input at one end, and on the other end of the electrical circuit, it would be turned into a mechanical tapping noise. And at the time, there's about 500 telegraph machines in London, but they were all on the same circuit. So if you tapped a message into one telegraph sending machine, all of the receivers around London, 500 of them, would all get the message. And there'd have to be someone there reading the messages and then figure out, oh, this is for this person, nowhere near me, Not my problem. But somebody would have to relay that message to the actual person somewhere in London. Not too efficient. My parents both grew up in rural Saskatchewan, kind of middle of nowhere, and they told me about growing up with what they call a party line. And this is kind of like what they had in London, a party line where multiple devices were on the same circuit. In this case, we were talking about telephones, this party line. So they'd pick up the phone. This is not a phone. But they'd pick up the phone based on the number of rings. So all the houses that are on this same party line would all get, their phone would ring at the same time. But if it's only one ring, it would be the first house. For 2 rings, it's meant for the second house, and for 3 rings, the third house, and so on and so forth. But my parents say quite often you would hear a lot of breathing on your phone calls because everyone would listen in. Small town, not much happening. So obviously, party lines are no longer around. We now have direct connections from point A to point B via telegraph or telephone. So my question was, how do they do that? Because in order to send a telegraph, you need a wire connecting point A to point B. And how can you have wires going from everywhere to everywhere else? That's not enough wires to do that. You need to send a telegraph from New York City over to Sacramento, the capital of California. You can't just have a wire from New York to Sacramento. Not only is it not possible to run a wire everywhere, but the signal wouldn't even be strong enough. So the network sets up all these little points and hubs and ways to get from here to there, bouncing around across. So the person tapping out the telegraph in New York City would be sending that message probably to Syracuse, which was a hub at the time for the Western Union Telegraph Network. And somebody, probably a young woman in Syracuse, would receive that telegraph and then retype that telegraph, retap it in the most basic way. They'd retap that in and plug that wire, sitting at the switchboard with all the holes and plugging wires around. They'd plug that telegraph and send it over to St. Louis, which was another hub. And then the same thing would happen in St. Louis. That telegraph would be received and resent and probably plugged over to San Francisco, maybe? I don't know. And then San Francisco would be like the local area, and they'd have lines out to the whole vicinity of San Francisco. And they could probably plug it over to Sacramento. And so your message ends up bouncing through all these switchboards, which are now known as exchanges, and they're all automatic and all that fun stuff. But at the time, that was a person at that desk connecting wires, essentially touching the ends of the wire together to get your message to send all the way across the country. At the time, you would be an A1 telegrapher if you could send about 30 words per minute, tapping away into the little sending device. 30 words per minute is not fast when you have a stockpile of messages. This was critical information to running the world. The stock prices, the latest news, the work orders, everything was sent by telegraph. And so the physical limitation of tapping it in a way that the human mind could understand was a bottleneck in this situation. So they decided to automate the process. They developed a machine that could more than double the speed of telegraph sending using a strip of paper. They would pre-write the messages into a machine that would punch little holes into the paper in a very specific way. And it would run it through the machine, and now the messages that were pre-written by multiple people into this one machine could be fed through at a consistent pace and send messages at full capacity 100% of the time, as much as that wire could handle. So at this point, they were pleased as punch in America, sending their Morse code telegraph messages crisscrossing the nation back and forth as fast as they possibly can. But there was no way to send a telegraph from America to Europe. Couldn't be done, because there was no wire. So they figured out they need to put a wire from America to Europe underneath the Atlantic Ocean. They tried doing this about 5 times before they got it right. Could you imagine the effort to put a wire across the ocean and then it only works for like a week. But eventually they did get a wire, a cable in fact, traversing the Atlantic Ocean, the transatlantic cable running from America to England, and they were able to send messages back and forth across this wire. Now, that presented them with a new challenge. 70 words per minute, 24 hours a day, 7 days a week. You couldn't handle all the messages people wanted to send. So then the next question. How do you take one wire and send more than one message through it? So the next big leap in telecommunication science was what they call multiplexing. That is how to send multiple signals through a single wire. Think about this, think about your television. You used to plug your television into a cable that was only one wire, but through that cable they received the red, the green, the blue, and the audio in order to present a television channel. And not just that, it was able to send hundreds of these channels into your TV through one wire, all at the same time. Every signal was there, waiting for you to click onto it. How? Multiplexing. The easiest way to think about multiplexing is to think about dear grandmama. And grandmama would send a box at Christmas time to the whole family. And you'd open up the big box, and inside the box was gifts for everybody coming out of the same box. Now, at the sending end, Grandma multiplexed this box because she put multiple packages, multiple signals into one transport. At the other end, it was demultiplexed as you opened up the box and took out the individual signals. Does that make sense? So at one end of the wire, you need to package multiple signals into one signal. And there's different ways to divide it up. One way is using frequencies. You can send multiple messages over different frequencies through the same medium. Just like FM radio waves travel through the air, but you can tune in the one that you want. So you have your wire, you need to package up your signal at one end on different frequencies, like this. And then you take all those different signals and put them together into one. At the other end of that wire, you receive the message, and then you separate those frequencies into the individual messages and receive that individual communication. So in order to grow our telecommunications network, we have layered up these technologies of multiplexing in different ways to cram more signal into a single wire, and then using automatic instant exchanges in order to transfer that signal anywhere in the world without anyone being involved. But it's all based on the same stuff. It all started with that telegraph wire, tapping away on one end, receiving the signal on the other end. So if, for some reason, you need to rebuild your telecommunication network from the ground up, that's everything you need to know. I hope you've learned something. I learned something. I'll see you later.